So don't forget to bring your calculator. If we have time, I'd like to go through that review sheet that I gave you the other day, so we're all kind of on the same page with regard to the problems you'll see on your test. Friday then, I will return your graded exam and we'll take a quick look at it, and then we'll start in on Unit 2 material. Okay, so we have 2 other types of problems using this factor label method. Now, the more you use factor label, the more it will be like, oh, just like rolling out of bed, okay? Honestly, the stuff that I graded and gave back to you today, it's really looking pretty good. So one of the things I guess I would mention, not with regard to density, but one of the things I would mention is if you have, like you have to go from meters to feet, and I know a lot of people just kind of Googled the relationship and then plugged in one conversion factor, but you're not going to have the Google tool tomorrow. So this is a case where clearly this is metric and this is English. Okay, so what's the one thing between, with regard to length, the thing that you're supposed to memorize, that exact relationship?
1 inch is equal to 2.54 centimeters.
Right. You are going into the test with that knowledge. So if you had this on the test to work, okay, and that's what JC was asking. So do I tell you how to get from point A to point B? No. Okay, but in this case, do you see where I can go from meters to centimeters? I know it seems like I'm going down. Yep, and centimeters to inches, and then I can go from inches to feet. Yep, so that's the sort of thing, right? So a couple problems now. These aren't equalities, but a couple kind of physical properties that we can use as conversion factors. For instance, the density of a type of matter. The density of something is a physical property of something, and we can use that as a conversion factor. For your blocks and your stoppers in lab, what did you guys do? You went and you weighed them, and you divided the mass by the volume, and you got density of your block and your rubber stopper. So density is mass per volume. And we can use that to go back and forth between mass and volume, and I'll show you what that looks like. Okay, but we're going to make sure units cancel. That's just it. We're all about units. Factor label method, making units cancel. So we're going to work a couple of density problems. For the first one, sometimes I have to read problems a couple times. But for the first one, we are going to go to grams from 242 milliliters. Okay. And so I can tell you right away, this first term, this 242 milliliters, I'm going to put that over 1, and that's going to be my first term. And then I'm going to use density. Now the next slide kind of unpacks density, the 0.792 G/ml. What that really means is 0.792 grams in 1 milliliter. That's the physical property I was talking about to use as a conversion factor. That's the unpacking that I'm talking about. All right, so the second one, we're going to, says what is the volume in milliliters? That's what we're trying to get to. The first term is going to be 50.0 grams. And again, we're going to use the density as a conversion factor. So the whole, I call this unpacking, the G/ml, what does that mean? It means, in this case, 0.792 grams in 1 milliliter. And we've talked about, when we unpack, the first number is approximate, APPROX, okay? And the 1 milliliter is by definition. Okay, so in other words, the 1 in 1 milliliter brings no uncertainty. So that's a physical property of methanol at this particular temperature. The inverse, if you guys are familiar with what inverse means, basically inverse means flip. So the flip is true with regard to methanol at this temperature. 1 milliliter will weigh 0.792 grams. We could go ahead and flatten it out. We could say the physical property for methanol at this temperature, 0.792 grams is equal to 1 milliliter. So those are 3 ways of kind of unpacking density. So now we're ready to go ahead and work those 2 problems with that in mind. Okay, so I always put as the first term the thing that's not a property. I usually put the first term is the thing we want to convert, which for the first problem it's 242 milliliters over 1. So it's all about making units cancel. So if I want milliliters to cancel, be left with units of grams, what can I put next?
1 milliliter on the bottom and 0.72 grams on top.
Yep, 1 milliliter on the bottom and 0.792 grams on top, exactly. And that's the density. That's the straight up density. So units of milliliters cancel, and then
Would it be helpful to put it in parentheses?
when I was working it, I probably would. My answer key would probably look like that, Becky. So, okay. So how do we need to round this? 3 sig figs, and what's the units going to be?
Grams.
Grams. Perfect. That's it. 192 grams. So we used density, which is density is units in this case of grams per milliliter, as a conversion factor to get from milliliters to grams. That's it.
Do you only need to use a decimal if it's like a bunch of zeros to show the uncertainty?
So is this what you mean? You got
After
you.
the 2?
Yeah, you told me 3 sig figs, and actually, if you put a decimal there, it would be the same number. Sometimes students feel better putting the decimal, so I could go either way. Very good. So that was going from milliliters to grams using density, and now we're going to go from grams to milliliters using density. So one of the things I've noticed for a few of you is that we need to be careful reading the information in the problem. So this problem said 50.0 grams. That's no small thing because, of course, 50.0 has 3 significant figures. 50, if it was just 50, how many sig figs are there? Not 2. Without the decimal. Just 1, yep. Versus 3. Okay, so what does my next term, I'm going to use density, I want grams to cancel, I want to be left with units of milliliters, so what does it look like? I want grams to cancel. So grams must be in the bottom. Oh, you guys are all doing it. So what? It's the flipped version or the inverse of the term we used before, isn't it? So if I put 1 milliliter over 0.792 grams, my grams cancel, I have units of milliliters. That's exactly where I want to be. So how many sig figs around this to?
3.
And then we divide this one, right?
Yep. 3 sig figs, I got 63.1 milliliters. So this is kind of actually a practical sort of thing. Given, if you know the density, you can go back and forth between mass and volume. So it's kind of nice. Okay? So we're skipping the next problem. That takes us to an assignment slide. So these will be due, I know it seems weird because you really should do them for Thursday's test, but I will collect them on Friday. So I'll collect these on Friday, okay? And don't do 109. So just do, don't do 109. Do 101, 103 in chapter 2. Okay. So I guess I don't have a lot to add for these. So kind of like what we did. And then this one is also due. If you read it a few times, if you've ever seen the Raiders of the Lost Ark, that opening scene where he goes into a booby-trapped situation and he's like, tries to quickly swap out the loot for his thing. And that's exactly what this is talking about. So basically, this is my bag of sand, and this is my bag of gold, okay? And he said the volumes are equal. So V of sand equals V of gold, okay? The problem is the densities are different. So, of course, which one's more dense? The gold is much more dense, yeah. And so they're saying use the density, which is given up here. We have the density of sand is this one. The density of gold is here. It says if we have a volume of 1.75 liters for both of them, what's the mass of both of them? Okay.
So you're just sticking the density over the volume, right?
You need to
And
use the
that-
factor label
and the
method.
factor
Yeah.
label.
Yes,
You're just
exactly.
sticking
Yep.
the different numbers.
Yep.
Like
Yep.
what we just did on the last.
It's what we just did, exactly. So for instance, if we look at the sand one, if we're trying to go from volume to mass, we're going to start with the 1.75 liters over 1. The density of sand is, yep, that 3.00 grams per 1 centimeter cubed. So do you buy this though? Let's think about this together. Centimeters cubed, that's the volume in my density. And I have liters. I can't use it right off the bat. I can't plug it in here. What were you going to say?
Isn't 1 centimeter cubed equal to 1 milliliter?
Yes. What you're saying is 1 centimeter cubed equals 1 milliliter. Perfect. Okay. But then what's,
You have to go from liters to milliliters.
yep. 1 liter is equal to how many milliliters?
1,000.
1,000, yep. So in those two things, to me, that's where I have to go
And
next.
that's where we go from we'd go from centimeters cubed to milliliters and then liters.
I probably would go I would go from liters to milliliters and milliliters to centimeters cubed.
Okay.
That's probably what I would do. Does that make sense? 1 centimeter cubed over 1 milliliter. Cool. So now how can I use, I've got volume of centimeters cubed, but my milliliters have canceled, my liters have canceled. Now how can I use density to get to grams? How many people think I can just plug it in like that? How many people think I need to flip it? What's that? Flip. If I flip it, then I have units of centimeters cubed in the top, and they don't cancel out. Yeah. So that's not going to work. So if instead I go with the 3.00 grams over 1 centimeter cubed as the density, then centimeters cubed cancel and I have units of grams. So for the second part, that's sand. That was all sand. I'll give you grams of sand. How will that look different for grams of gold?
Just
The
the last number.
19.3 is gonna go where the
Yep.
40 is.
Yep, this last term is going to be different. Because this is going to be the density of gold instead of the density of sand. All right. Okay, so that was using density to go back and forth between mass and volume. Volume, mass, mass, volume from density. So one last problem I want to work is how to use weight percent as a conversion factor. And you guys are probably already familiar with using percent as a conversion factor, but I want to use it as the factor label method. I'll show you what I mean. So when you guys did your experiment with the egg, you guys broke the egg into 3 parts and then did a calculation to come up with the weight percent of each of your parts, okay? And so that weight percent was grams of A in 100 grams of the egg. So that's the definition of weight percent. So we're gonna do a problem here, and we're gonna go with weight percent. You can go back and forth between grams of component and grams of solution, and I'll show you what I mean. So in the first one, oh, by the way, let's just start at the beginning. On the next slide, you're gonna see this unpacked. You have to unpack it to use the factor label method. So 7.2% sucrose means, this is what I mean by unpacking it, 7.2 grams of sucrose in 100 grams of mixture or solution. That's what it means. And it's a physical property of the sugar solution. And just from the units, you see how we can use it to get back and forth between grams of sucrose and grams of solution. So the first one, we are how many grams of sucrose? So I'll put question mark grams of sucrose.
And the only reason we had to do this was because it's the mass percent, right?
Right. And then over here, we're starting with 65 grams of solution, SOLN for solution. Solution is the mixture. And for the second one, what is the mass of solution? So we're question mark grams of solution. Goes over here on the right. Contains 3.3 grams of sucrose. And in both of those, I'll show you on the next slide, but in both of those, we can use that weight percent to get from left to right. So here we go. So that physical property of that sugar solution, that sucrose solution, when it said 7.2%, you have to unpack that to use it in your problem. So like I said, what does that mean? Well, it means there are approximately, that's approximate, APPROX, approximately 7.2 grams in, by definition, 7.2 grams of sucrose in 100 grams of solution. So how many sig figs do we have there? 2. Yep. 2, that's it. So we can kind of think of that to use it in our problem. So to work the problem, oh, sorry. So here's my little here's my warning. So we're all about using units and having units cancel and all that. But when you're dealing with weight percents, you have 2 weights, you have 2 grams. So the word is explicit. We need to explicitly say grams of what over grams of what. It's grams of component, in this case sucrose, over grams of mixture solution, in this case, yep. Yep. All right, so to work the first one, the first term is going to be that 65 grams of solution over 1. I put that in parentheses. So I want grams of solution to cancel. I want to be left with grams of sucrose. So how many people think we'll just use the regular unpacked, the unflipped version of weight percent? Does it seem like, yeah. Well, my units of grams of solution, I think so too. Yep, me too. So if I just simply bring the 7.2 grams of sucrose over 100 grams of solution, now my units of grams of solution cancel. I have units of grams of sucrose. That's perfect. You think 2 significant figures there? Yeah. So I got 4.7 grams of sucrose. Any questions? Okay, What's to work the next one, what's my first term gonna be?
3.3 grams of sucrose.
Very good, 3.3 grams of sucrose over 1, perfect. Now, if I want grams of sucrose to cancel, I need to put grams of sucrose in the bottom. So what does that term look like?
100 on the top.
The 100's on the top, exactly. 100 grams of solution on top, 7.2 grams of sucrose on the bottom. So my units of grams of sucrose cancel. And how do we need to round this? How many sig figs? 2. That's it. And my units will be
Grams of solution.
grams of solution. That's it. Very good. 46 grams of solution. Any questions about that? So again, we're just using weight percent as a conversion factor.
Are we doing the next assignment then too?
Yes. So these will be due. We'll take a look at them. Now, just recently let's see, you guys, how do I say this? The online part to this class, where you use HawkNet, click online, and you can actually just see the grade book for this class, okay? Just recently, there's a tab that says doc sharing. I revealed all of the answer keys. So actually the answer key for these 3 and the answer key for, if you can find them, they're out there, okay? I went ahead. Usually the answer key goes up after I hand back the graded assignment. But they're up there now, so you might want to take a look. So, these are all going for the mass of sucrose given these weight percents of sucrose. And these are all going, or this is, let's see. I'll just kind of leave you to these 2. Yep, there's 3. And then this last one. Okay? So again, the answer key, what's that?
I was just saying it's the grams over grams again, you just break and
Mm-hmm.
3.5 and unpack it.
Mm-hmm. All right, very good. So, what I'd like to do next is, let's see if I can pull this up. Is kind of go around the room and I will ask you questions. Okay? You just love this. This is our review, okay, since we got time. Anybody, I have an extra copies of our, anybody want an extra copy? Actually, I can print them out. This is kind of what your test looks like.
Is it just
Okay, so this is how this will go. We'll go clockwise, so I'm going to start over here with Austin. So for instance, the first one says, which of the following describe chemical properties and which are physical properties? So what if I said the color of grass is green? Is that a physical property or a chemical property? It is a physical property. Very good. We'll do a few of those, okay? Becky? What?
Can I have that, one of those papers?
Oh, sure. What if I would say, paper is combustible?
What was that, which was the name of
Is it is that the fact that it will burn, is that a physical property or a chemical property?
Physical?
What do you think this would be?
Is that how they get burned?
But when I burn it, is that a chemical reaction? Okay, so the fact that I would have to burn it to check its burnability,
Uh-huh. Would it make it chemical?
it's a chemical property. Very good. Let's do one more. All right, JC, what if I say water boils at 100 degrees?
That's chemical.
Why do you think it's chemical? Heat, okay, we're adding heat. But when I boil water, did I change the water molecule at all?
Oh, no. It's
No.
physical.
So it's a physical property, yep, so they're harder than you think sometimes,
Yeah,
very
it's
good.
like,
So I guess you can really tell the difference is just if the molecule is still the same after you make the
Right.
change.
Because we burned yours, so we no longer have hay burner, and we just changed the
we're just
physical phase of
changing
yours.
the heat.
Yeah. The next one's kind of similar, so it says classify these not as properties, but as a physical or chemical change. Okay, so, I'm drawing a blank.
Oh, my name?
Yeah,
Tyler.
Tyler, that's what I thought. But aren't you Tyler too? No? Jeremy. Okay, Tyler. Hey Tyler, so what if, tell me if this is a physical or chemical change. What if I take wood and I chop it into little bits?
That's physical,
It is physical, why?
because you're not changing the molecular structure.
Right, exactly, not changing the molecular structure. Physical or chemical change, column. So what if I take aluminum and it's usually solid, and what if I subject heat to it and I melt it?
It's still physical.
Still physical, very good, very good. So physical or chemical change. Are you serious? Okay, I forget your name.
Okay, it's
Alicia, duh, sorry. So one more. What if this is kind of an interesting one. I don't know if you like cotton candy. Sure. So we take sugar and we heat it and kind of add air. What do you think?
I don't know, I feel like that could really go like either way because it's not really sugar anymore because it's like, it melts because of the heat. So that would be like physical, right? But-
Yeah,
So is it physical?
it is physical, assuming you don't burn it along the way.
Yeah.
Yeah.
Okay, so physical?
Yep. Okay,
Did you say you're adding air to it though?
what's that?
Did you say you're adding air to it?
Yeah.
Okay.
Well, you're just using air to kind of change its, instead of being like a crystalline now, it's kind of fibrous. Yeah, it's kind of weird. Okay, Mr. Eichert, I can't think of your first name. Logan, okay. So let's go on to the next one. Let's see, give an example. Well, let's see. Let's do it this way. We talked about intensive and extensive properties. Intensive, which one's independent of amount?
Intensive?
Intensive, very good. So that wasn't my question. What about, what if I had 5 pens like this, and I kind of would call this purple, okay? So a property, of it is that it's purple. Is that intensive or extensive?
Extensive. Intensive.
Why? It is intensive, and you told me intensive is independent of amount, so the color purple,
It's intensive because it's really purple?
because it's purple if I have 1 or if I have 5.
It doesn't matter on the, it doesn't matter like, it doesn't like, it doesn't, I don't know what I'm trying to say. It doesn't like affect the weight or like it doesn't affect how
Right.
like the density of it or
Yeah,
whatever. The
yeah.
color purple doesn't matter to it.
Right, very good.
It's only one thing.
Very good. Thank you. So, Tyler? No, Tyler, Jeremy. Jeremy, so what about, let's go with the pens. How about mass? The mass of this might be maybe 250 grams. What if I have 1 or 5? So is mass intensive or extensive?
Extensive.
It is extensive, because why?
Depends on the amount of it.
Yeah, it depends on the amount that I've set aside. Yes, that's exactly it. Okay, so questions about the metric system. So we're back to you, Austin. And this could go a few different ways, but how would you fill in, Austin, blank millimeters equals 1 meter. What would you put there?
1,000 millimeters.
Very good. See, you'll do great. Okay, so back to you, Becky.
Okay.
How would you fill this in? 1 kilogram is equal to blank grams. 1 kilogram is equal to blank grams.
Is it? I don't know.
Kilogram, grams.
Do I have a cheat sheet?
Not on this test.
I learned it with the 10 and the exponents. So
Okay, that's cool.
is it 6 zeros?
No,
Minus 6?
that would be mega. So it's not 6, it's
0. Or
it's not 10 to the 6th, it's 10 to the
third?
3rd. Yep, 10 to the 3rd. Or,
Okay.
yep, so, let's see. I'll ask it this way. So we have kilo here, milli here. There were 2 other prefixes to memorize. So what do you think, JC? What was another one?
Centimeters and inches.
Centi?
Oh,
Yep.
that's
Can you give an example of centi?
So 1 inch is equal to 2.54 centimeters.
Very good. Well, what about within the metric system? So, blank centimeters is equal to 1 meter.
1 centimeter is equal to
Yeah, that's good. 1 centimeter is equal to.
0.01
Yep,
meters.
yep, very good. Very good. Do you remember the last metric prefix to memorize?
Micro.
It is micro. Awesome. So can you come up with an example of a statement using micro in it? Okay, let me get you started. See, how about 1 microgram is equal to how many grams?
That one's 6.
Is that what it is?
It is 6, but is it going to be
Oh,
10 to the positive 6 or 10 to the negative 6?
-6.
It is. Very good. Very good. So know those four prefixes. Okay. Okay. Item number 5. How many significant figures are in these quantities? So we're over to you, Colin. Get some space here. What if, and these are all non-exact numbers or by definition, so there's got to be kind of a little wiggle in them. How about 13.02? Colin.
4 6s.
There are 4 sig figs. Very good. On to you, Alicia. How about 0.032?
3.
3, and you're counting this one?
Yes.
Okay. Now this guy is not significant.
Just kidding too.
Thanks for playing along, though. There's 2. Very good. Very good. How about, in that vein, 0.0000705? Let's stick with Alicia. Are these 0 significant?
No.
Okay.
So there's 3.
There are 3. You got it. There are 3 there. Perfect. Okay, the next one, Logan. This one, the instructions will read just like this. Write them in scientific notation and round them to 4 significant figures. So here it goes, Logan. What if I had 3,000,000 $255,615. So,
3.256 times 10 to the 6th.
any questions for Logan?
Why are you so smart?
Okay. He knew this was gonna be the question for him.
Yeah.
I'm just kidding. Okay, so let's go a little one. How about 0.00005963554?
Fun. It's gonna be 5.964 times 10 to the negative 6.
That's what I get. Perfect. Any questions? I'm liking it. So we're back to you, Austin. Let's do one more. How about if we have a negative number? Negative 532,641. 4 sig figs, scientific notation.
5.33 times negative 10, 10 to the 5 power.
Close.
Negative 10 to the 5th power.
This one, and I did this on purpose, this actually goes with the coefficient. So, I'm gonna do that. And one more thing, so I think you need one more sig figure. So 4 significant figures.
5.326.
Perfect, I'm liking it. I did this one on purpose, and this is gonna be positive. And then we tack on the negative, so
So
you
keep the negative if it's a negative number.
Mhm.
But how come we didn't round the 2 up from the 6?
What if it was
Because-
3 sig figs?
Yeah,
But since it's 4, you leave the 2 and the 6 alone because the 4 is under 5, so you don't have to round the 6 up.
Oh, okay, gotcha.
yep, yep.
I was looking at the board.
The 7 through 12, I don't have a lot of like things to throw at you about working problems, so those are gonna be kind of like the homework that you handed in and the problems that we just did with density and weight percent. And any questions about those?
Did you just do like converting like inch cubed to centimeter cubed?
I can do that.
Yeah, and when you have a problem like that, you don't have to break it all the way down to just like an inch or a centimeter. You can still, like, you don't have to do it 3 times, right? We can still leave it
Well,
as a cubed answer.
Let's see, I think so. So what if we were going, so we're gonna go cubic inches to centimeters cubed, right?
Sure.
Okay, so let's go with 431 inches cubed to centimeters cubed. So, you guys would tell me 1 inch is equal to
2.54 centimeters.
2.54 centimeters. Okay, so actually I could say quantity cubed and quantity cubed if I wanted to, however I want to do that. But what I said I would probably do is 431 inches cubed over 1. So I probably would do this.
3 times.
So what does this look like?
The 1 inches cubed is on, well, 1 inch would be on the bottom.
Yep.
If you do it 3 times, it'd be cubed.
But if we were to just to do it 1 time, we could still leave our answer in cubed form. Okay.
if you could do it, 431 inches cubed. And we could basically plug in 2.54 centimeters over 1 inch quantity cubed.
Okay.
Excuse me, cubed. But the catch here is you need to recognize that I am taking 2.54 times itself. 3 times, yeah. It'll be the same thing. Any other questions? So what room are we in tomorrow?
319, 14.
14, 314. Ding, ding, ding. Okay. All right, so if you have any last minute questions, I'll be around tomorrow morning at 8:30 or so. Let's go for it.
These are me and Becky's homework.
Thank you.
You're welcome.